Number 3 is about a projectile that has been fired from the rooftop of a building that's 50 meters high, and it's shot with an initial velocity of 200 meters per second. So V naught, and here's H naught. And do they give you any... they don't give you any theta, do they? Do they give you... Okay, it's fired. They do. They say it's fired horizontally. So you need a theta, but that means... So here's your building, and it's shot horizontally out like that. And it's going to fall. So the initial theta is equal to 0. So that's interesting. All right, so then the first question says, what's the vertical change in height after 2.5 seconds? So here's our time. Where will it be when t equals 2.5? What will the height be? Okay, so let's see what our y equation gives us. So remember, our y equation is equal to t v naught sine theta minus 1/2 g t squared plus h naught. So let's write that out and see if we can't find how high it will be. So y equals time, so 2.5, initial velocity is 200, and sine of 0. And you guys, we might not need a calculator for this one. This could be like how a test question be given you without a calculator, because you know what sine of 0 is. What's sine of 0? 0. So we actually know this is going to be 0. This part's going to be 0. So like nothing, and the angle of nothing helped it. It's just going to do a straight fall. All that's left is this gravity. Now we're doing in meters per second. So that would be 1/2 of 9.8, or 4.9 times 2.5 quantity squared plus 50. So it's 0 minus, and then 4.9 times 2.5 squared times 50. Now, do you know what 25 times 25 is? It's 625, right? That should have been one of the ones you learned. So 2.5 squared times 2.5, well, 2.5 times 2.5 would be 6.25. So we have 4.9 times 6.25 plus 50. Now you can do 625 times 49 and put your decimals in and see if we can't do this without a calculator. So this would be 45. Oops, don't get that wrong. It's 18, 19, 20, 21, 22. And that's 54 plus 2 is 56. Put the 0 down, 20. That would be a 2, so that's 10. And 25. So altogether we get 5, 2, 6, 0, 3. 30, and then, okay, it's not that big. We have to put our decimals. We have 3 decimals, so it's 30.625. And we're going to add 50. So we get 50.000. So we get 80.625. So the answer would be 80.63 meters. That is wrong. So what did I do wrong? I know what I did wrong. This is good at practice. Guys, this was negative and this was positive, right? So I had to take off the 30 from the 50. So, bad me, back up. Don't you just love having to erase your own notes on a video? That's what makes it fun. So 50 minus 30.625. So do a little subtraction here. That would make that 10, but then 9, then 10, then 9, then 10, then 9, and then 10. So 5, 7, 3, and this would be 9. So 19.38. Sound better? 19.38 feet. Nope, meters. So it is possible to do these without a calculator. Just watch your signs like I didn't, and then fixed it. All right, so that was part A. I'm going to erase some of this work here so that we can have room to do B on the same slide. So let's just put the answer up here. Equals 19.38 meters. All right, part B. Part B says B wants you to determine the horizontal distance, the total horizontal distance it went before it hit the ground. Now, hitting the ground, we know, is this when y, the y equation, or height, is equal to 0. Gives you, if you set that equal to 0, it gives you the time. How long did it take? Okay, how much time did it take to get here? Okay, and so we set y equal to 0, and so then that would be 0 equals t. That's what we want first, because we need that t to put into the x equation. T times v naught, which is 200, and that sine, still a sine of 0. So again, this part is just going to be 0, minus 4.9 t squared plus 50. Okay, so let's see what we can do with that. We have that equal to 0, so we get 4.9 t squared equals 50. As we had a negative here, if we put that negative 4.9 on the other side, so t squared equals 50 over 4.9. So t is plus or minus, and I'll talk about that in a minute, the square root of 50 over 4.9. So let's put that in our calculator. You get t is equal to 3.19. Okay, so that's how long it took. Now, why is this plus or minus? Well, remember this is a quadratic, right? So it has to have, if you're drawing the whole quadratic, it would be 0 here in negative time. And of course, we don't have negative time. But that's the two places right here and here that it reaches 0 for the parabola. So that's where the negative is. You just use the positive time, obviously. Now, we put that into our y equation. So we'll have to find, our x equation, because it asked for the horizontal distance. We just needed the time. So x is equal to 3.19 times v naught, which is 200, times cosine of 0, which everyone knows is 1, right? Oops, just the cosine is 1, not the whole thing is 1. So that would be 3.9 times 200, okay? So you would get 780. 780. Did I do that right? My bad. It's 3.19 times 200. Make sure you do it right. 3.19 times 200 is 638. So, finally get 638, and it would be meters high. All right, it would be, no, that's the total distance it went, how far it went. So that's the x distance, not how high. 19.38 was how high. All right, that was number 3.